This is a demonstration of pivot interactions. The student up here has a pair of scissors and plans to cut this string. The program gives the individual student considerable ability to put in different types of measuring instruments. So for instance, you could put in and try to measure the angle of this inclined plane. You can put in a ruler, as I have here, that starts at the initial position of this ice block. You can have a timer, which right now is set to 0, but they haven't cut the rope yet, so let's advance along several frames. Try to find the point where it just, you can see the string is beginning, it's been cut, it's beginning to go away. Looks like right about there. Certainly has gone there, maybe back one frame. So this we can reset. So there it is. We can set that to 0 seconds. And now we can take data, in fact. Now, among the things right now I have set for a mass of 420 grams, and I have it set for ramp angle number 9. I can change the ramp angle, and like I showed you, I can measure the angle to see what that angle is. What's nice is that as the student changes anything, the mass or whatever, in the background, it's actually changing the video, so it's going to change the data that they get. They don't have to do it themselves. The program does it. So if you change something, there it is, it's changed. And you can see the angle's now changed, so you'd have to go back up here, and in fact, you would have to alter your ruler and move it up, and again set it where you could start. But the student has the feeling that they're actually controlling somewhat the experiment rather than clicking through a bunch of different clips. And it makes it all integrated. I'll put it back to where it was. So here you've got a very small, I think I put the first one, I remember what I had it at. Maybe it was at number 10. So let me go ahead and I'm going to try to move that down. Not quite got it right, but close. All right, close enough for right now what we're doing. So move forward, go to 0 seconds. It was at 0 centimeters at that point. It looks like this one was a little different, so go back just a little bit so it wasn't exactly the same. Let me change it and reset that to my 0 time. And I can go in here and actually start recording data. So I had 0.0 centimeters at 0 seconds. Then let's say maybe go down 1/10 of a second, or a few tenths. Let's see here. It looks like 1/10. So 1/10 of a second, I'm sitting here looking, it's just a little bit over 2. So it looks like 2, maybe with an uncertainty of 0.2. You can put an uncertainty column if you want. So you put some uncertainty points in here. So 2.0, and this is 0.1. And if you want to put in an uncertainty column here, you put a column to the right, put uncertainty, next, that would be in centimeters, variable would be dx, and so don't really have one for this one, but certainly this one here is probably in the order of maybe 0.2 centimeters. Depends on how well you want to think you can see that, where the 0 point is. You're also gonna be, you can set up your axis and select what they're doing. So for this one will be distance, and yes, it'll have an uncertainty. And this one here will make this time. So there's my first data point, there's my second data point, automatically graphed up there for me. I'll be able to fit curves through my data in a minute. Let's do another point. So now I'm looking at 5, 6, 7, 8 point, maybe 3. So 8.3 plus or minus 0.2. Add 0.2 seconds. I can go back up here and I can do another data point. So now I'm at 18.5. That was incorrect, 0.3, thank you. And you can see the data is pointed here. Maybe we want to fit that. Let's try different graphs. Proportional graph doesn't work very well. Maybe we want a curve fit. Do a quadratic. Fits very well. Obviously, it's a constant acceleration problem. We get the components. We can go and compare it. You can ask questions built into it. But the idea is that you can go now and change things like the mass. And you redo the experiment. Now, you may have to slightly move your thing, and you may have to go forward to figure out where 0 is. But now we can run the experiment again and see whether or not a mass affects. It looks like that's where I need to reset my. And we can go and check to see whether or not, by taking the same set of data, whether mass affects the location and the graph. Or is it independent of mass? And we can change the ramp angle and so forth. So the student, in essence, can control the experiment through these frames, and the video that you're putting into this system is automatically changed. Now, Pivot itself actually acts as a learning management system that you can make up your own activities, put in your own slides, put in your own video. The problem with doing that for, say, like the planetarium is that you'd be paying for that. But there are other ways to do it, such as in a lab view thing. In terms of making it, the most obvious way to do it would be to get the students over in engineering or CS who are doing that and see if you can get that integrated into a project, such as, for instance, software development course, and see if Merisha, one of them, would make that their project is to develop this software for you that you then put your videos into to make the experiment work. And you could, each one of the students could have a different type of project, and then there could be another group that builds the base LabVIEW interaction. All right, but anyway, that's the idea. In this way, a student actually gets more of a feel. In fact, you could see that when you click on this, instead of that zip around there, what happens is you get a picture of the telescope, and the telescope starts rotating around with the sound and everything until it locks on, and then it says switching to, you know, telescope view, and you actually have the picture of the planet. that comes into frame. Or maybe if when it's rotating, if you actually are seeing things change across the screen on your computer out at the observatory, then that's what you'd want to film. Even though you normally think of those as things, you can use what I'm doing. I'm doing a screen capture. And that screen capture is seeing what I'm doing around here. I can screen capture anything. You could screen capture the control panel that shows the picture on your observatory computer program. Anyway, that was the idea, just for something for you guys to think about.